Imagine simultaneously being born, growing up, and getting old somewhere out there in the universe. Sounds bizarre and unrealistic. And still, according to the block universe model of the world, that's exactly what happens with you, me, and other living beings on our planet. It's as if someone drew pictures about every moment of your life and then just piled them one on top of another, creating a giant block of all things that ever happen at any time and at any place. The future, present, and past exist at the same time and are equally real. The block has 4 dimensions. 3 of them are spatial. It's length, width, and height. There's one more, time. To make it easier, let's picture our world as a cuboid, which is basically a 3-dimensional rectangle. Its height and width represent 2 of the 3 spatial dimensions of the universe. As for the 3rd spatial dimension, we'll replace it with time. At one end of the cuboid, we'll drop the Big Bang. And at the other, there will be the end of the universe. Let it be a big crunch. Our cuboid is filled with every single event that ever happens. Even this moment, when you're watching this video, exists somewhere in the block. Now, we perceive today as the present, yesterday as the past, and tomorrow as the future. From this perspective, it seems that time passes. But in the block universe, time doesn't flow. There's no specific present moment since the notions of the past and future are relative. You see, we are always located wherever we are, which means that everyone remains in the present. But the block universe theory doesn't deny the notions of earlier than and later than. These relations remain no matter what and regardless of where anyone is located. For example, Molly the mammoth is located earlier than Marcus the tiger. This relation between Molly and Marcus will remain unchanged regardless of whether you're located later than Marcus or earlier than Molly. This way, in the block universe, now is any time you are located at. Past is any time or events that are earlier than your location, and future is any time or events that are later than your location. It sounds like in the block universe, we could travel in time since it's just another dimension. Well, it could be true, but of course, things just have to be more complicated than that. Traveling in time is way more difficult than traveling in space, but it's not impossible if you travel very, very fast. Traveling at extremely high speeds results in time dilation. We can travel into the future at a reasonable percentage of the speed of light, and to get to the past, we can use wormholes, shortcuts through space-time. But if we can travel in time in the block universe, can we change the past? Not really, because if you do, it'll create a contradiction. Keep in mind that, in this universe, the past is the same as the present or the future. What is past to you is future to someone else. And when traveling to the past, you're going to someone else's future. In the past, you'll act just like you do in the present, but you won't be changing the past. All your actions are already predetermined in the block universe. At the moment of the Big Bang, it's already clear that at one point, you'll travel to the relative past. Just like what you do tomorrow makes tomorrow the way it is and has always been, what you do in the past makes it the way it is and has always been. The events in the block universe do not change. As a time traveler, you don't suddenly appear in the past. It's always been the case that you're located in the past. And nothing a time traveler does can change anything in the block. Instead, whatever you do at any time makes that time the way it is.
Time runs like a river. It has direction, always advancing. It has a certain duration, periods between events you can measure. Time feels real, always there, unstoppable, moving forward. But what if I told you that time might not exist? Some physicists and philosophers claim that there might be no such concept as time, and we should take this possibility of the non-existence of time seriously. You see, recently physics has been in crisis. For the past century or so, 2 extremely successful physical theories have been used to explain the universe. Those are the theory of general relativity and quantum mechanics. Quantum mechanics describes how things work in the super tiny world of particles and their interactions. As for general relativity, it provides an outlook on the bigger picture, for example, gravity or how objects move in space. And even though both of these theories seem to be working really well, they are believed to conflict with one another. That's why some scientists think that they need to be replaced with a new, more general theory, like quantum gravity. This idea might be able to explain how gravity works at the miniature scale of particles. Apparently, it's incredibly difficult to produce the theory of quantum gravity, but it might be possible to do it with the help of string theory. It replaces particles with strings, vibrating in 11 dimensions. But there's one problem. Even though string theories do provide several models describing the universe, they don't make any clear predictions that can be tested by experiments to understand which model is the correct one. There's one more idea known as loop quantum gravity. According to it, the fabric of space and time is made of super tiny chunks, loops. But the most remarkable aspect of this theory is that it completely eliminates the concept of time. Now suppose this idea turns out to be correct. Will it mean that time doesn't exist? Well, the answer is kinda complicated. Everything depends on what the word exist means. A philosophy professor from Cambridge University claims that the three basic properties of time, a present moment that is special, the flow of time, and its direction, come from our mental states and not from the physical world. So we sense this arrow of time because our minds add a certain subjective ingredient to reality. At the same time, Einstein's theory of relativity supports the idea of the block universe, a four-dimensional space-time structure where time is like space. It has its own coordinates in space-time. Time is tenseless there. Thus, the future and past are as real as the present. Does it mean we're being fooled by our human perspectives? Is the feeling that time passes and has a certain direction false? Well, we can imagine our world as a three-dimensional place where stuff happens gradually over time. Or it might be a four-dimensional space where nothing actually happens because nothing changes. It's all here at the same time, past, present, and future. The main idea of relativity is that there's no absolute space and no absolute time. Everything is relative. Trying to think about time in the context of the universe, you realize that you need to isolate part of it and call it, let's say, your watch. And time is basically the relationship between some parts of the universe and that thing you called your watch. Another scientist says that time is just a collection of snapshots describing our reality while continuously changing one into another. Here, you hit play. Here, you're blinking while watching this video. And here, you're taking a sip of your coffee. Without these changes, there wouldn't be any notion of time. The changes are real, but time is not. Our brain sees these changes and constructs a sense of time, believing that it's flowing. What do you think? Is time just a social construct, or does it really exist?
The morning is cloudy, but it isn't raining. So you grab your bag and head off to work. You're halfway there when it starts drizzling, then raining, then pouring. There's only one thought in your head as you're dashing through wet streets towards your office building. If only I could hop in a time machine and go back in time. I'd have put that umbrella in my bag. Unfortunately, going back in time is not possible. But guess what? We still managed to travel in time. But let's start from the very beginning. More than 100 years ago, a famous scientist called Albert Einstein, I bet you've seen his most popular photo, came up with a theory about how time works. He gave it a nice little scientific name, the theory of relativity. According to it, space and time are linked together. Another point is that our universe has a set speed limit. Nothing can move faster than the speed of light, which is 186,000 miles per second. Okay, you may say, but what does it have to do with time travel? Well, the theory of relativity also claims that the faster you move, the slower you experience time. and several experiments prove this to be true. For example, let's say you have two clocks set to the exact same time. You leave one clock at home and take another one with you while traveling by plane. What's important here is the fact that the plane is going in the same direction as Earth. After your plane finishes its flight around the world, you can compare the time on the two clocks. You find out that the clock that traveled with you is a bit behind the clock that remained on the ground. Because of this, GPS clocks are corrected. GPS satellites travel around our planet at tremendous speeds, around 8,700 miles per hour, and more than 12,000 miles above the surface of Earth. This speed slows GPS satellite clocks down, but the altitude speeds them up. As a result, the clocks on GPS satellites experience time at a rate that is slightly faster than 1 second per second. And if this difference in time wasn't corrected, you wouldn't be able to use GPS to figure out your exact location. In any case, this is probably the closest thing we have to time travel. You see, our planet is constantly moving around the sun at an average speed of 67,000 miles per hour. The sun, along with the entire solar system, is, in turn, circling the center of our home Milky Way galaxy at a staggering 140 miles per second. And the Milky Way itself is also moving. It's spinning at a speed of 130 miles per second. Those are some really dizzying numbers. And now imagine that in order to get to the past, all this space matter must also turn back and return to its original position. Just admit it, it's absolutely impossible. By the way, even though we can't exactly travel back in time, we can look at the past, thanks to NASA's space telescopes. They help us see stars and galaxies that are insanely far away. It takes the light coming from them ages to reach Earth. That's why when you observe those distant worlds, you see what they looked like a long time ago. Now, what if time travel was somehow possible? Wouldn't all the fun be spoiled by the time travel paradox? You know, like finding yourself in the past and accidentally preventing your parents from meeting each other? The problem is that Einstein's theory of general relativity theoretically allows a person to travel back in time and come in contact with their past self, which can potentially endanger their existence. But you can breathe out. Some scientists at the University of Queensland have recently claimed that this paradox might not actually exist. They say that even if you made some changes in the past, the timeline would self-correct anyway. In other words, it would still ensure that whatever event sent you back in time would still happen. One more study claims that even if some changes happened in the past, they wouldn't drastically alter the future.
If the universe is everything, then there is nothing external for it to expand into. But we know for sure that it does expand. So the question is, what exactly is it expanding into? According to the theory of cosmic inflation, the universe was once filled with large amounts of energy. It was similar to hypothetical dark energy, but much greater in magnitude. It made the universe expand faster and faster. As a result, the universe was getting colder and emptier. And then, after growing this way for a very long, possibly infinite amount of time, most of this energy got converted into matter and radiation, which triggered the Big Bang. The Big Bang was the moment when the whole universe was squeezed into a tiny, super hot, and extremely dense ball we call a singularity. And all of a sudden, when it was less than 1 second old, this tiny ball started to unpack at speeds we can't even imagine. It was so hot that particles were moving extremely fast, crashing into one another and creating pairs with their opposites, like matter and antimatter. When the universe was 1/100th of a billionth of a trillionth of a trillionth of a second in age, it experienced an incredible burst of expansion that we know as inflation. At that moment, the universe doubled in size at the speed of light. And after that, it doubled in size at least 90 more times, growing from a subatomic-sized formation to a Gulf-sized structure almost instantly. After this burst of inflation, according to NASA, the growth of the universe continued, but it slowed down. As the universe kept expanding, it started to cool down, and matter formed. 1 second after the Big Bang, and the universe was already filled with neutrons, protons, electrons, anti-electrons, photons, and neutrinos. If we somehow managed to observe the universe when it was just a trillionth of a second old, we'd see that it was the size of Earth's orbit around the Sun. When the universe was a mere 1 second old, it was too hot for nuclear fusion to occur. At that time, its radius was just 10 light years, which is enough to enclose the 9 nearest star systems we know about. When the universe was 1 year old, it was smaller than our home galaxy and unbelievably hot. Finally hot enough to start nuclear fusion. When the universe was 3 years old, it was roughly the size of the Milky Way galaxy. When matter started to dominate radiation, which happened when the universe was around 10,000 years old, the size of the universe was about 10 million light years. It would be easy to think of the Big Bang and the resulting expanding universe as an ordinary explosion, where everything is expanding from a central point. But it's not a good analogy. There's a better one. Look at the surface of an inflating balloon. It'll be a two-dimensional equivalent of our three-dimensional universe. The balloon fabric will be space. These dots marked on its surface will represent galaxies. You see, they're moving apart as the balloon expands, but it happens only because the fabric, representing space itself, is expanding. The galaxies aren't moving on their own, and there's no central point for the expansion. The balloon is expanding into the third dimension, and that's where the analogy is getting trickier. Does it mean that our universe is expanding into some higher dimension? If there's no larger multiverse and our universe is all there is, then there's nothing outside of it. Not even a vacuum, which is still part of space. It means there's no point in asking what the universe expands into. If there was a two-dimensional being on the surface of our expanding balloon, they would be able to observe all distances in its surface 2D world getting larger. But they wouldn't see the third dimension into which the balloon is expanding. The same goes for us. Three-dimensional creatures. We see the distances between galaxies growing, meaning the inflation of space, but we can't perceive additional space dimensions into which the expansion is moving beyond our three. Even if space is indeed expanding into some higher dimension, our current knowledge of physics doesn't allow us to find out anything about it. It's likely to be beyond our comprehension.
What is the fastest moving thing in the universe? That we know about, of course? It's light. Its speed in a vacuum reaches 186,000 miles per second. If people could travel at such insane speeds, we would have already explored hundreds of new worlds which are inaccessible to us today because of how far they are located. Interestingly, while traveling at the speed of light, you would experience time differently. Your mass would become infinite, and you would slow down. That's because the faster an object moves, the more mass it has. That's why, in real life, traveling at the speed of light in the conventional way doesn't seem possible. Okay, another question. Could we slow down the speed of light? In 2015, a team of scientists from Scotland claimed they had found a way to do just that. They sent protons through a special mask, altering their shape. And in this malformed state, super tiny particles of light started traveling way more slowly than regular protons. It's true that the difference in speed was almost imperceptible, but the fact they had managed to do it was amazing. It means that the speed limit of light isn't as unchangeable as we thought before. It's another question why anyone would want to slow down light as if it's not slow enough as it is. Ah, I see. This last statement might sound confusing, but let me explain. We humans are used to traveling at unhurried speeds of 60, 70 miles per hour on the highway. So to us, the speed of light seems to be unreachable. But how about this? If we reduce the observable universe to the size of our planet, crossing the Milky Way galaxy would be like walking a few houses down the block to visit your friend. And still, it would take a whopping 100,000 years if you traveled at the speed limit of this Earth-sized universe. This example shows how incredibly slow it would be for a spaceship to explore other worlds at the speed of light. Crossing our home galaxy would span more than 100 human generations. And even if we let humans be and concentrate on protons dashing across the solar system, the speed of light would still turn out to be too sluggish. Astronomers have calculated that it takes light almost as much as 45 minutes to travel the distance between the Sun and Jupiter. And it takes light 5 hours to reach Pluto. When you look up at the sky at night, you see stars as they were a long, long time ago in the past, thousands of years. That's how long it takes the light they emit to reach us. So now that we know that the speed of light is indeed pretty slow, we can try to find the answer to the main question. Why is it so? So far, the only answer astronomers have is because. A tiny bit more satisfying version of this answer sounds like this. The universe is designed in such a way that protons move with such velocity. There's no specific reason why it should be this way, it's just the way it is. As you see, the answer is a non-answer at the same time, and we're simply stuck in this slow universe. But would it be better if light was much faster? What would our lives look like if the speed of light was boosted by a factor of 1,000? Then, a spaceship moving at the speed of light could cross the Milky Way in less than a century. A trip to Alpha Centauri, the closest star to Earth other than the Sun, where potentially habitable planets may dwell, would take less than 2 days. Computers and different networks would function way faster due to enhanced optical speeds. But at the same time, the Sun would also become much hotter, around 1 million times hotter. And it would mean only one thing: Earth would be boiled in no time. So we should probably be grateful for our slow speed of light. If it were even a bit faster, our planet wouldn't exist. This tool is always available, 24/7. It improves your accuracy and reduces the number of errors. It can perform boring and repetitive tasks instead of you. You've probably guessed that I'm talking about artificial intelligence. But what if I also told you that it has the potential to make humanity disappear? Leading computer scientists and technologists are worried. They believe AI poses a risk of extinction to our civilization. And it's so serious that the situation calls for global action. Experts claim that super-powerful AI systems can only be developed after we become confident that their effects will be positive and risks manageable. AI is advancing so fast these days that it has raised concerns about the potential negative consequences of such rapid development. They might range from mass job losses and copyright infringements to instability in different spheres and the spread of misinformation. There are also those who are afraid that people will one day lose control of the technology altogether. The thing is, current AI has yet to achieve AGI, which stands for Artificial General Intelligence. But once it reaches this stage, it will potentially be able to make independent decisions. And doesn't it sound truly terrifying? But the most alarming thing, researchers at Microsoft say that GPT-4 has shown sparks of AGI. It turned out to be capable of solving difficult tasks spanning math, coding, medicine, psychology, law, and many other fields. And it didn't need any particular prompting while doing this. So, are we on the road to superintelligence? And why are most people not worried about it? It might be because we are confused about the very term AI. Most people associate AI with sci-fi movies and don't realize it's our reality now. Nowadays, AI is a broad topic. It ranges from our smartphones to self-driving cars to something that can change our future dramatically and irrevocably. Let's clear things up. We should stop thinking of AI as robots. A robot is just a container for AI. Sometimes they might mimic the human form, sometimes they don't. But AI itself is inside. AI is the brain, not the body, if it has any. Have you ever used, let's say, Siri? I bet if you're an iPhone owner, you have. So Siri is an AI, and the voice you hear is a personification of that AI. And guess what? There's no robot involved whatsoever. Now, back to the dangers AI might present. There's a chance that soon, AI chatbots will become more intelligent than humans. And then, AI may start, or be used, to generate misinformation capable of destabilizing society. In the worst-case scenario, however unrealistic it may sound, machines might become so intelligent that they will take over the world, which would lead to the extinction of humankind. There are other, no less pressing concerns. For example, AI could start playing a big role in making decisions affecting our lives. Imagine people becoming so dependent on AI that they can't live without its advice and guidance. They rely on it in all spheres of their lives, from buying groceries to choosing a vacation destination to picking a name for their child. Sounds scary, doesn't it? Lots of jobs, more than 300 million all over the world, will be, and already are, at risk because of AI. It happens as certain tasks and job functions become automated. This tendency might also affect administrative jobs, the legal sphere, architecture, management, and more. At the same time, we must acknowledge that AI is beneficial for many sectors. Experts predict a 7% increase in global GDP thanks to it. For example, some areas of science and medicine are already taking advantage of AI, developing new medicines and treating some diseases. For the time being, countries are trying to pass special AI-related legislation. It's supposed to classify AI into 4 risk-based categories, deal with fakes, and make companies register their algorithms with regulators.
With each passing day, we learn more and more about the world around us. But some of the most fundamental questions that have been bothering humankind for centuries remain unanswered. For example, where does the universe end? Or even better, can it be infinite? We know that our universe is around 13.8 billion years old. That's quite a lot, but it may be even older. You see, some parts of the universe can be too far away for the light from those mysterious regions to have reached us. That's why we have the notion of an observable universe, which is the parts of the universe we can actually see. What happens beyond is unclear, and we might never find out the truth. But the question of whether the universe is finite or boundless depends on its geometry. The general theory of relativity allows 3 possible shapes for the universe: open, closed, or flat. The open one resembles a saddle, the closed one looks like a sphere, and the flat one can be compared to a sheet of paper. After performing complex calculations and observations, astronomers are almost certain that our universe is flat, and this might mean that it is infinite. On the other hand, it could simply mean that the universe's geometry is so complicated we can't perceive it. There are also other studies that suggest that the universe might be closed. Therefore, it's probably finite. Unfortunately, we're unlikely to find out the truth anytime soon. Now, if the universe was finite, could it have an edge? Since its formation all those billions of years ago, the universe has never stopped expanding. So, now, the regions of space at the edge of the observable universe are way farther away from us than when they emitted the first light. It means the edge of the observable universe is around 46 billion light-years away in every direction. Imagine a sphere with a diameter of 92 billion light-years and a volume of 410 nonillions, which is 410,000 billion cubic light-years. Here you go. It's our observable universe. But no one knows whether these ginormous numbers are the real limit of the universe, with nothing beyond. It would actually be very arrogant to claim that. The chances are there's a whole different world beyond the edge of the observable universe. But even if the universe is finite, it might still not have an edge, like our planet. It's obviously finite, but have you ever seen its edge? Unlikely. So everything depends on the geometry of the universe. Okay, if the universe is infinite, it indeed can keep expanding without getting bigger, since you can't get bigger than infinity. When the universe expands, space itself inflates, which creates additional distance between objects. And astronomers are sure that it happens no matter whether the universe is infinite or not. Now the next question is what the universe is made of. Everything we can see around and in space with the help of telescopes and other instruments is known as normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Around 27% of the universe is dark matter, and almost 3/4 of the universe is dark energy. Astronomers wouldn't even know the thing existed if, some time ago, they hadn't found out that, instead of slowing down, the expansion of the universe was accelerating. It means there is some enigmatic force counteracting gravity. It got the name of dark energy. At the moment, we have no idea what dark matter and dark energy are. As for the 4.9% we do understand, about 74% is hydrogen, 24% is helium, and the rest is heavy elements. Another intriguing question is whether the laws of physics are the same everywhere in the universe. Well, there's no convincing reason why it should be the case, but when scientists tried to measure tiny differences in the constants ruling the forces of nature, it turned out that these laws were the same everywhere and at all times. At the same time, some studies have shown that one constant determining how electric charges interact might have been different in the past. But most researchers agree that this finding is controversial and currently unproven.
Our vast universe is home to phenomena such as star-devouring black holes, rapidly rotating pulsars, radiant nebulae birthing stars, and countless galaxies. Yet it may not be endless. There could be a distinct edge, a cosmic boundary. Let's embark on a journey to that possible frontier. Visualize the universe as a massive layered structure. At its core is Earth, enveloped by our solar system, which is in turn housed inside a galaxy within this grand universe. As we journey beyond our solar system, passing by the planets from Mars to Neptune, we encounter the heliosphere. Here, the solar wind's velocity plunges dramatically, giving way to the near-stagnant wind at the heliopause. Beyond, the ship faces the force of the interstellar wind. Two remarkable emissaries from Earth, Voyager 1 and Voyager 2, now reside in this region. They revealed the heliosphere's uneven shape. Venturing further, an asteroid belt known as the Oort cloud becomes visible, believed by some scientists to source Earth-bound comets. Beyond lies the expansive Milky Way, spanning around 106,000 light-years. Guiding our journey is a cosmic map, identifying our location in the Laniakea supercluster. However, there's more. At a greater scale, the Hydra Centaurus supercluster emerges. At the universe's maximum observable scale, a surprising revelation awaits, evidence suggesting a universe boundary. This edge, located an astounding 10 billion light-years away, is a testament to time and evolution. During such a lengthy voyage, our sun might wither or explode, and the Milky Way might merge with the Andromeda Galaxy. Our endpoint is the Eridanus supervoid, a vast empty stretch spanning 1 billion light-years. This void might result from an unfathomable collision, our universe meeting another. This leads to a tantalizing notion of multiple universes, where every choice leads to alternate outcomes in parallel realities. Imagine our universe as a bubble. Eons ago, another bubble universe brushed against ours. Their gravitational interplay caused cosmic distortions. As they separated, a piece of our universe might have been taken, leading to the creation of the Eridanus supervoid. Eridanus supervoid covers a region of space about 1 billion light-years in size. This makes it one of the largest known voids in the universe. This superwave is associated with the so-called cold spot in the cosmic microwave background radiation. The temperature in this spot is lower than the average temperature of the background radiation. The exact origin and nature of Eridanus supervoid is still a subject of research. This object provides scientists with a unique opportunity to study the structure and evolution of the universe on large scales. Yet, perceiving the universe's entirety remains a challenge. Like an ant on a basketball, we see a consistent horizon due to our 3D viewpoint. But adding dimensions could change our perceptions. Could black holes, with their powerful gravitational influence, offer a passage to these other realms? The vast expanse of our universe is filled with intriguing structures, mysteries, and phenomena that continually challenge our understanding of the cosmos. The Eridanus supervoid, with its immense size and enigmatic nature, stands as a testament to the universe's capacity to astonish and confound us. And for those intrigued by the enigmatic nature of black holes, we invite you to explore more in our other videos. Dive deep into the mysteries of these cosmic giants and join us on a journey of understanding and wonder.